Let's take a look at section 5.6, groups and rational numbers.
All right, the number system. Now, this blue line is my number line. The first numbers that I'm going to throw onto that number line are the counting numbers, 1, 2, 3. Notice I have the square root of 16, but the square root of 16 is 4. So actually, they're exactly the same, but I wanted to throw that in there because I wanted you to realize these numbers can be written in different forms, but whenever you simplify them, you still get 1, 2, 3, 4, and 5. These are called the natural numbers. You see that script N, and those represent the natural numbers. Now, the next set is going to actually take the natural numbers, and we're also going to throw in 0 and all of the negative numbers, the negative natural numbers. All right, so the negative values. So I'm looking at all of these numbers now, and all of those numbers together are called the integers. So notice that the integers are all the negative numbers, 0, and I union. Do you remember that from a previous section? I'm going to join them together with the natural numbers, and they all make up the integers. So any of these numbers that you see and dots and so forth on both sides make up the integers. Okay. The next is going to be, take a look at these little blue values. And from our last section, you should recognize these as rational numbers. So if you throw in, you're going to take all of these numbers that we already have, and we're going to add in anything that can be written as a fraction. Remember that this is 0.333, and that's negative 1/3. Okay, so that could be written as a fraction too. So if you can be written as a fraction, which remember 3 can be written as a fraction, it's 3/1. 5 can be written as a fraction, it's 5/1. All of these numbers that you see, regardless of their color, those are the rational numbers. Remember that the rational numbers can be written as a fraction, and that's all that this fancy little terminology means. Anything that can be written as a fraction, I combine them together with the integers and I get the rational numbers. Now, the next set is the one that we call the irrational numbers. The irrational numbers are not rational. That's just the easiest way to put it. So irrational are only the purple numbers, okay? Notice I don't have this unioned with any other set. The irrational numbers are a set kind of their own. They live in their own little world. And so that you just need to make sure like all of these numbers are they're all interwoven together, but the irrational numbers, they are just irrational. They form their own little world. So remember we talked about those examples in the last section. Okay, then the last thing is if you throw all of these numbers, any number that you can put on this number line, it doesn't matter how small, how large, repeating, fractions, decimals, infinitely long numbers, they are going to be a part of the real numbers. So every single number that you see written here is a real number. So for example, let's take the number 1, okay? The number 1 is a natural number. It's an integer. It is a rational number because it can be written as 1/1, okay? And it is also a real number. So the only thing that number 1 is not an irrational, but it is all of these other things combined. If we look at the square root of -2, so this purple one, it is only an irrational number and it is also a real number, but it is not a member of any of these three. So this square root of -2 would only be irrational and real. So hopefully that will help you get through. This is just a reminder because we actually talked through this section and these properties earlier in the year, but I thought it was a good thing to remind you to help you get through some of this section. All of the other parts of this section you should be able, again, to, Dr. Farmer does a good job with the lecture notes, and the text also does a good job, I think. If you are confused, by all means, send me an email and let me know, and we'll get you some help. Thanks a lot.
Now we're going to take a look at a couple of examples on this number line. And what I want to do is I want to first look at the number 22. And you're going to have a couple of examples on your homework where you're going to be asked to take a number and name all of the different number systems that that number belongs to. So let's do that with the number 22. So I want to basically take the number 22 and let's define all of the different number systems that 22 belongs to. So I want to see, of all of these different systems, which one does 22 belong to? So we know that 22 is a part of the natural numbers. We know that it is also part of the integers, and so that it's going to belong to the Z. It will also be part of the rational numbers because you can always put 22, 22 can always be put into a fraction over 1, and so that will also be a rational number. So if it's a rational number, then it's not going to be an irrational number. So you won't ever have one that is a rational and an irrational at the same time. And then if you are a rational number, then you're also going to be a real number. So 22 is a member of all 4 of those different number systems. So, so that would be those different 4 number systems. Now let's take a look at negative square root of 3, which is this negative long decimal number. And so let's take a look at that. And this one is going to be a little more limited. So this one would not be a natural number or an integer. You cannot make this into a fraction, but it is an irrational number. And so because it's not a rational number, then that makes it an irrational number. So it would be in part of that Q prime. So that would be part of that. And then it would be part of the real number system. So this one only has 2 number systems that it is a member of. So you're going to have a few questions on your homework where you have to go through, and it'll give you a list of some different numbers and ask you to pick out all of the different number systems that that number belongs to. Okay. Now let's look at another couple of examples where you're asked to express each of the numbers as a decimal, and then you're asked to round your answer to 4 decimal places if needed. So in some of these examples, you're going to notice that negative numbers are going to be in different places in a fraction. So in this particular example, the negative is in the numerator. So you have a negative 31 over 6. And so you can simply just put this into your calculator, type in negative 31 divided by 6, press enter, and then you will want to round that to 4 decimal places. And so whenever you do that, you're going to have a negative 5.1667. So make sure that you use 4 decimal places. This is where WebAssign is very particular. If you were to round this to 3 decimal places or not round correctly, then you'll get this one wrong. So this is where it is particular. Looking at another example, notice that the negative is out front. So this is actually, we could have written this with the negative 19. So just like this one, and it would have basically been the same thing. So you can have it written with the negative in the top, the negative in the bottom, or the negative out front, and it doesn't matter. So I wanted you to know that it doesn't really matter either way. So put that into your calculator the same exact way. Negative 19 divided by 27, and then you would round, and that would be a negative 0.7037. On these examples, you're going to be asked to change the terminating decimals to fraction form, and they want you to simplify your answer completely. So make sure your answers are in simplest form. So 0.125, what we're going to do is we're going to change that to 125 over 1,000. So I simply just took this and wrote it from decimal form to over 1,000 and put it in decimal to fraction form. But now this is not in simplest form, and the reason why I know this is that I can divide the numerator and the denominator by a common fraction or a common form. So in this particular case, I can divide top and bottom by 125. Now let's just say you didn't know that you could divide it by 125, but you knew that you could divide by 5. Well, you can just keep dividing by 5 and keep dividing by 5, and you just keep going, and that's fine. I just happened to know that 125 would divide into 1,000. So that saves me a few steps, but you can keep dividing and just keep going if you need to. So when I do that, I would divide it out, and this turns out to be 1 over 8. So this, the decimal 0.125 is the same thing as the fraction 1 over 8. All right, now let's look at one more, 8.34. Now 8.34, I'm going to rewrite that first as 8 and 34 over 100. So 8 and 34 over 100s. Now, if you remember writing in mixed fractions, I'm now going to take and write this as an improper fraction. So the way that we do that is we say 100 times 8 plus 34, and that gives me 834 over 100. Now I'm ready to reduce top and bottom. And so actually I can just divide the top and bottom by 2. And when I do that, I get 417 over 50. And that is as simple as that fraction will get. So it will not simplify any further. So that would be as simple as that gets. And so you would actually put that into WebAssign in that form. Now we're going to look at several properties that you're going to need to be able to identify. So the first is the associative property. I like to call this the friends property. So it's pretty easy to identify. So the associative property, typically you'll see this written with 3 different numbers. So you have this for addition and you have it for multiplication. So this just means that I kind of think about it as 3 friends sitting in a booth at her around a table. So these 2 friends can sit next to each other, or these 2 friends can sit next to each other. It doesn't really matter. You're all still sitting around the same table. So that just means we can add these 2 together first, or we can add these 2 together first. It doesn't matter. You still get the same answer. It works the same way for multiplication. So in multiplication, I can multiply these 2 first and then multiply it by 7, or multiply these 2 and then multiply it by 9. I'm going to get the same answer. So you just need to be able to recognize that when you see these 3 numbers written like this, that this is an example of the associative property. All right, now the commutative property. The commutative property, I recognize that by saying I commute to work. Commuting to work just means that if you go in one direction and then you come back, it's the same amount. And so, although that's not always the case depending on traffic, right? So I might have to change my explanation of that, but in an ideal world. So it just means that 8 plus 3 is the same thing as 3 plus 8. or 8 times 3 is the same thing as 3 times 8. So it doesn't matter the order in which you do it. So that's the commutative property. Those are by far the two easiest properties that there are. Now it's going to get a little harder. The distributive property, I kind of think about it as like distributing or handing out, when I hand out worksheets or something in a class and I distribute things to everyone. So basically you just have to make sure that everybody gets one. So we're distributing this 4 to everybody in the parentheses. We have to make sure that everybody gets a 4. So when I distribute, the 8 has to get a 4 and the x has to get a 4. So that's 4 times 8 and 4 times x. So that's how I describe the distributive property. So just being able to recognize that this is an example of the distributive property. So that one's not too bad either. Now the last couple of properties are a little bit tricky. And so this one is called the identity property. And the way that I remember this one is that I think about identity as using a 0 or a 1 to see yourself. So I think about this guy seeing himself in the mirror. And so 0 and 1 are known as the identity numbers in mathematics. And so here's how that works. So 6 plus 0 is 6. So 0 is the magical number here for addition. So you can add 0 to any number to get that number back. So use 0 to see yourself with addition. All right, the same thing works with multiplication with the number 1. Use 1 to see yourself. So if you want to multiply with multiplication, you just multiply any number by 1 and you get that number back. Okay, that seems really simple. And in its simplest form, it is very simple. So these two examples right here are the simplest forms of the identity property. And when we see it simple like that, we say, hallelujah, thank you. However, we can't always have things simple. And so sometimes we see things really ugly and we see things like this. And you're just like, how in the world do we go from something like this to something like this? Well, let me just show you how this actually is. If you look very carefully, this right here, AB squared over all of this, and this right here is exactly the same. AB squared, xy to the 6 minus 3xz, xy to the 6 minus 3xz. Now, so that's exactly the same on both sides. This right here, notice right here what this says, 14 over AB, 14 over AB. So this is a really, really, really ugly fraction. However, any number over itself, what is that? It doesn't matter that it's disguised. I've always said, and I've repeated it several times in this course, any number over itself is considered to be what number? It's considered to be the number 1. So that really ugly number right there is actually the number 1 in disguise. So basically, this whole thing right here is basically the identity property as well. Because what I have done is I have said, I took some number, albeit it's an ugly number, and I said that I took that same number and multiplied it by 1, albeit it's an ugly version of 1, but I basically did the same exact thing that I did right here. It's just really ugly. So you have to look out for tricky versions like this. And so anytime you have something really ugly, I want you to think about, oh my goodness, are they trying to pull that one trick on me where they're trying to pull that trick where they're making one look really weird? They probably are. So be on the lookout for that. That's the identity property. They've disguised one to make it look weird. So there you have it. Okay, our last property is the inverse property. It's similar, but a little bit different. And this one also talks about 0 and 1. So rather than getting yourself back, you're actually going to find a number and you're going to get the answer of 0 or 1. So you're actually looking for a 0 or a 1 as your answer. So, so that's where this is a little bit different. So let me show you how this kind of looks. So in other words, you started with 5. We're looking for this number right here. We are looking that there exists this other number, -5, which is my additive inverse. So the inverse of 5 is -5, or it's the opposite. So that when I add these together, I get 0. All right. And then I have the same thing for multiplication. I'm looking for this little guy right here, which is 1/12. That's the inverse or the reciprocal or the multiplicative inverse. Big words, I know. But that's the inverse of 12, so that when I multiply them together, I get 1. All right, so both of these, notice I'm not disguising 1 in this case. I'm finding another number so that when I multiply these together, I get 1. So that's where these are a little bit different. So that's the inverse property. The last thing we're going to go over is something that's called a group, and you're going to be asked to check whether the set and operation form a group. So in order to form a group, we're going to look at this numerical set, which in this case is the integers, and we're going to look at the operation, which in this case is addition, and we want to know if it forms a group. And in order to form a group, you have to satisfy 4 different things. So we're going to go over those 4 different things. So the first thing is called closure. So closure just means that you can take any 2 elements from the set. So any 2 numbers out of the set, and you can perform the operation, which is adding, and your answer will be in that set. So in other words, we can take any 2 integers, so 1 and 5, and if you add them, you're going to be back in the integers. So just thinking real quickly, 1 plus 5 is 6, and 6 is an integer. Any 2 integers that you add together, you're always going to be back in the integers. So this works. So closure is no problem. So that is good. We're good to go on that one. Now, number 2 is the associative property. The associative property we talked about earlier. This one is pretty easy too. It just means that we can add any 2 together. So this is for addition. So if you think about plugging in some numbers here, so 1 and 2 and 3. So we can say 1 plus 2 is 3, and 3 plus 3 is 6. Yep, that works out good. Or we can say 1 plus 2 plus 3, which 2 plus 3 is 5, plus 1 would be 6. Everything is great. So it doesn't matter the order in which you do it. Everything works fine. That is associative, and everything works good. So that's no problem either. Now, identity. You can add, so basically they want to know, is there a number that you can find that is an integer? It has to be a number that's in the integers that you can add to any number to get that number back. So in other words, we have the number 0. and 0 is one of the integers. And so 0 can be added to any number and I get that number back. So the identity property works for the integers because 0 is an element of the integers. So this works good for me. The last one that has to work is the inverse. So this says that you have to be able to find the inverse of a number in order to get 0. So they want to know is for any number that you pick, I just picked 9, just as an example, can you find the inverse of 9 so that when you add it to 9, you get 0? Okay, because I'm using addition here. And so can you do that? Yes, it doesn't matter what you find. There is an opposite. You would have the opposite number. In this case, it would be -9. And so it doesn't matter what number you have, you would just do the opposite number. You would be able to find it. So because of all of that, and because you got 4 smiley faces here, that means that this set and operation forms a group. Okay, so in this case, the answer would be yes, this forms a group. Now, I will tell you, most of the time, you will always find that most of the time, number 1 and number 2 is usually pretty easy. Number 3 and number 4, those are the ones that you usually, if you're going to find a problem with it, it's going to be in one of these two. So those are usually the cases where you find the most problems, where it's going to throw out and you're not going to have, everything that you need. So anyway, hopefully that will help you get through the problems in section 5.6.